Okay, so here we have a question where we're showing a particle with a weight of 29 newtons, and that's a key point here. The weight is 24 newtons. That's not given the mass. So if we can, it's already in a force because it's given in newtons. So let's label that force 24 acting straight down. There's a force P acting at an angle and a force Q acting horizontally to the left. So we can see this particle is in equilibrium, so all the forces must balance each other out. So let's look at horizontal components and let's look at vertical components. And then the only force that's really irritating us is really this P newtons up here, which we can break into its we can break into its horizontal component acting along in the positive x direction and a vertical component acting in the positive y direction. So now if we just put all those things together, and I can now have a look at this force, analyze this force in the force triangle. It makes it a little bit easier. So this force is just the force P, just looking at the vertical and horizontal components of that. We know that the hypotenuse is P, this must be a right angled triangle, and the angle in here is 30 degrees. So we can break into the components. So the opposite, SO, from SO katoa, means that this is P sine 30 degrees, and we know that this must be P cosine 30 degrees acting the horizontal. Then let's resolve in two different directions. Let's resolve, get two equations down. Let's resolve horizontally for this particle. Now, what's acting to the right positively? Well, the horizontal component of P, this P cosine 30. So P cosine 30 is acting across positively. Oh, that's a rubbish negatively. Take away Q, because that's acting in the negative direction, negative x, and as it's in equilibrium, it must be equal to 0. Let's call that equation 1. And let's resolve vertically to get our second equation, because this equation's got two unknowns. Let's have a look. What's acting up? Vertical component of P, P sine 30. And what's acting down? Minus 24 is acting to 0. Now I know you can start to solve this, but if you look at the mark scheme, that actually having those two, for this 6 marks, having those two equations down is actually worth 4 of the 6 marks. So I always get you to draw the diagram, draw the force diagram, and then write these two equations down. So we've not even started solving the question. Now we could start solving it. It asks us, A, in the question, asks us to find the value of P. So that's easy. So I'm going to choose equation 2. Equation 2, just rearrange, and we know that P is equal to 24 divided by 24 divided by sine 30. I'm sorry about my handwriting today. So we just do that, and we get the answer that P is equal to 48 newtons. That's our third mark. And let's look at part B. Part B, we want to ask us to find the value of Q. So all we need to do is, well, we've used equation 2, so let's use equation 1. And we look into equation 1, and we've got the value of P now, so we can rearrange, and we find out that Q is equal to, P is 48, so using the answer button on our calculator, 48 cos 30, so 48 times cosine 30, and then therefore Q is equal to 41.6 newtons, and let's round that to 3 significant figures. And therefore we're done. Easy. Just to highlight, 2 marks for that equation, 2 marks for that equation, and then you only get 1 for actually finding each of the answers. Okay? Fairly straightforward equilibrium problem.